Okay. So, uh, skin is the main organ of the integumentary system, and it has how many layers? Two. Outer epidermis, inner dermis. Okay. Under the skin, there is another layer which is not a part of the skin, that is called hypodermis. So we'll talk about those layers. Then we'll talk about the glands of the skin. Skin has sweat glands, sebaceous glands. Okay, so we'll see what kind of secretion comes from those glands. Then we'll talk about the dermis and its structure. Of course, we'll talk about epidermis and then dermis and then water loss. As I said, the main organ or part of the integumentary system is what? The skin. Okay? And accessory structures of the integumentary system are hair, nails, and glands of the skin. Only the glands of the skin. Functions. By covering the whole body, your skin protects your body. Make sense? By covering the whole body, your skin does what? Protects the internal structures. Now, skin provides three types of protections: chemical, biological, and physical. By chemical means, by biological means, and by physical or mechanical means. How skin gives protection? By chemical means. Skin secretes acid mantle, acidic secretion. That means low pH. You remember low pH means acidic, right? Below 7 is acidic, right? So skin secretes low pH secretion, chemicals, that means acidic secretion. And you know that acid can kill the bacteria or inactivate the bacteria. How skin provides protection by biological means? Skin has phagocytic cells. What are the phagocytic cells in the skin? One is, all of you know, macrophages. Remember, macrophages, they engulf the cell that has many processes. So, engulf the antigens, microorganisms, or dead cells. Another type of phagocytic cells in the skin are dendritic cells. So, those two types of phagocytic cells can engulf the microorganisms, bacteria, virus, or dead cells, and provides protection. Physical or mechanical protection is given by keratin and glycolipids. Keratin is a highly specialized protein. Remember, keratin is a highly specialized protein present in the skin, hair, nails. So, everywhere in the integumentary system you have keratin. And this highly specialized protein provides protection against water, so it doesn't let the water pass through it. So waterproofness, okay, is given by this protein. So water and water soluble chemicals cannot enter into the body from outside through the skin. Another chemical, that is glycolipids, that also prevents the water from entering through the skin, entering into the body through the skin. So keratin, a highly specialized protein, and glycolipids. And these two chemicals also prevents the lipid soluble chemicals, for example poison ivy or organic solvents pass through the skin. Regulation of body temperature. Your skin helps to regulate the body temperature. How? You all know, we talked about homeostasis, remember that? If body temperature increases, sweat glands secrete water, right? Sweat. So water gets out from the body, and water has what? High heat capacity, remember that? So a small amount of water can take a lot of heat out from the body. Is it clear? So when body temperature increases, your brain has a structure that is called hypothalamus. Okay? So if body temperature increases, what happens? Skin has the receptors, you know that. Those receptors send signal to the hypothalamus of the brain. Hypothalamus of the brain, and hypothalamus sends signal to the sweat glands in the skin. To secrete water or sweat, right? And when water is released, water takes a lot of heat out with it. Okay? So that is one way skin lowers the body temperature. Is it clear? Number two, when body temperature increases, hypothalamus also sends signal to the blood vessels of the skin. To the blood vessels of the skin, and causes vasodilation. Dilate the blood vessels of the skin. Make sense? So what will happen? You tell me. If hypothalamus sends signal to the blood vessels of your skin everywhere, right, and dilates the blood vessels, then more blood will circulate in the skin. Make sense? More blood will flow, and from the blood it will easily get out through the skin. Okay? So that is another way skin lowers the body temperature. So those are two ways. One is by sweating, another is by increasing blood flow in the body surface. Cutaneous sensations. Housing cutaneous receptors. In your skin, you have pain receptors, right? That's why you feel pain. You have temperature receptors, right? So you can detect hot or cold. Make sense? You have touch receptors in the skin, right? So if someone touches, you can tell. So those are due to the presence of what? Receptors. Is it clear? In the skin. And there are some diseases, like if someone has lack of touch receptor, then what will happen? The person will not feel any sensation, right? There is a disease in which the pain receptors are lost. So even something bites you, scratch the person, cut the skin, the person will not feel pain, which is not good. Is it good?
No.
Not feeling pain is not good. Okay, pain is a good protection, right? If something bites you, you feel pain, right? And move away. If something hot touches, you move away, right? So all those are for your protection. Metabolic functions. With the help of sunlight, skin produces cholecalciferol that I mentioned before. So skin produces cholecalciferol. So this is sun, this is the skin, produces a chemical that is called cholecalciferol, which is an inactive form of vitamin D, precursor of vitamin D. Then blood takes the cholecalciferol to the kidneys, and inside the kidney you have converting enzyme that can convert cholecalciferol to calcitriol. This one is E, sorry, cholecalciferol, okay, calcitriol, which is active vitamin D, okay, inside the kidney. Because of the presence of converting enzyme, cholecalciferol is converted to calcitriol, active form of vitamin D. Excretion through the sweat that secreted from the skin. Some metabolic wastes are getting out from the body, as well as salt, and that's why if you taste the sweat with your tongue, it is salty, right, and kind of metallic taste, because some nitrogenous wastes and salt get out from the body through the sweating. So those are important functions of the integumentary system. Now we'll talk about the structure and types of skin. In your body, you have two types of skin, thick skin and thin skin. Most part of your body is covered by thin skin. Only in few locations you have thick skin. Where you have thick skin? Palms, right? And sole of the foot. And if you see the structure of the skin, skin has two layers. You remember I said skin has two layers. Outer layer is called what? Epidermis. So this is epidermis, and the inner layer is much thicker than epidermis, and this is the dermis. Okay, so those are two layers of the skin. Under the skin, you have a layer which is not a layer of the skin, remember, that is called hypodermis or subcutaneous layer. Sub means under, cutaneous means skin. So it is under the skin, it is not a part of the skin. Hypodermis. Okay? So skin has how many layers? Two. Okay. Outer epidermis, inner dermis. Which one is thicker? Dermis is much thicker than epidermis. Okay. And under the skin, you have a layer that is called hypodermis or subcutaneous layer. Make sense? And that layer contains a lot of what? Fat or adipose tissue. Adipose tissue or fat. One route of injection is subcutaneous injection. Have you heard that? Injection is given intramuscular, right? In the muscle, intramuscular injection. Intravenous, have you heard that? Directly into the blood. And another is subcutaneous. That means in the hypodermis. So which one is the first acting? Blood, because it is IV, intravenous, right? Going directly into the blood. Make sense? So blood will take it to the site of action. Then after that, intramuscular. If you inject into the muscle, a lot of blood goes to the muscle, right? So blood will take it. Subcutaneous has a lot of what? Fat, right? Adipose tissue. So if you inject drug here, it will slowly enter into the blood because fat has very little blood supply. Make sense? Less blood supply in the fat. So if you want any drug to work for a long time, like several hours, you will prefer which one?
In the fat.
In the fat, right? Subcutaneous. Example, insulin, right? We give under the skin insulin because we don't want to get insulin every hour, right? We want to slowly, work in the body for a long time. So that is the subcutaneous or hypodermis. Now, epidermis has 4 or 5 layers. 4 or 5 layers in the epidermis. In thick skin, epidermis has 5 layers, and thin skin epidermis has how many? 4. Make sense? Thick skin has how many? 5. And thin skin, 4 layers. Make sense? So 1 layer is missing in thin skin, right? Okay. So what are those layers of the epidermis? If you start from the bottom, a single layer of stem cells. These are stem cells, okay? This layer is called stratum basalis. Stratum basalis. A single layer of what kind of cells? Stem cells. Is it clear? So these cells can do what? Quickly multiply to produce new cells. Have you heard stem cells? Stem cells do what? Multiply to produce new cells, right? So from this layer, new skin cells are produced. Is it clear? Okay. That's why this layer is also called stratum germinativa. Germ layer, germinal cell layer. That means stem cell layer. Then you have another layer stratum spinosum. Stratum spinosum has the cells like this. These cells have spines, spiky processes. So that's why this is called spinosum. Okay? Also called prickly layer. So if you see the cells, they have many spikes or spines. So stratum spinosum. Okay? In this layer, you have plenty of melanin granules and dendritic cells. Melanin, anybody?
Skin color.
That gives the color of the skin, right? Dark pigments. Okay? So the person has more melanin, the skin is what? Darker. Right? Lack of melanin, skin is white. So that gives the color of the skin, and so lot of melanin as well as dendritic cells. You remember I said 2 types of cells provide biological protection: macrophages and dendritic cells. They can engulf, right? So dendritic cells are also present in this layer. Then you have stratum granulosum, granular layer. If you see the cells in this layer, cells have a lot of what? What do you think? From the name, You can tell. Lot of what? Granules. Yes. Makes sense, right? So a lot of granules inside the cells. That's why this is called stratum granulosum. Stratum granulosum. What type of granules are present inside these cells? Keratohyalin and lamellated granules. Keratohyalin and lamellated granules. And then these granules give waterproofness as well as toughness of the skin. Toughness as well as waterproofness to the skin. The next layer is stratum lucidum. This layer is a transparent, like a glass, layer of glass. And that's why it is called lucidum. And remember everybody, this is the layer which is absent in thin skin, okay, but present in thick skin. So this is stratum lucidum. Only present in the thick skin, absent in thin skin. Then the outermost layer of the epidermis is stratum corneum. It is a layer of many layers of flat cells. Anybody remember flat cells are called what? Squamous, right? So if many layers of flat cells, that is called what? Stratified squamous. Very good. So stratified squamous layer. This is called stratum corneum, outermost layer. Corneum. Okay. Okay. And many of these flat cells, remember, are dead flat cells, but filled with that highly specialized protein I mentioned before, that is called keratine. So these cells are heavily filled with keratine, that is specialized protein that gives the waterproofness. Okay, so the water cannot enter into the body from outside, which is good, right? Like sometimes you sit in the bathtub or swimming pool for a long time, you swim, water doesn't get into the body, right, through the skin. If it does, when it will come out, it will be big, right, like a lot of water inside your body. That doesn't happen. So the waterproofness, right, is important. That is given by keratine, which is heavily present in the stratum corneum. All these cells are filled with keratine, and many of these cells are dead keratinized cells. Okay. Now, dermis. Although dermis is much thicker than epidermis, dermis has only 2 layers. Outer layer gives 20% thickness of dermis, which is the papillary layer, and inner layer gives about 80% thickness of the dermis, which is called the reticular layer. So outer papillary and inner what? Reticular. Make sense? Those are 2 layers of the dermis. Now, in 2 layers, you have 2 different types of connective tissue. Papillary layer is areolar type tissue, connective tissue. And inner reticular is dense, irregular type connective tissue. Make sense? Do you remember areolar and dense, irregular? You should, right? You remember that. So areolar is loose and dense is tight and strong, right? So loose areolar is the papillary layer and dense irregular is reticular layer. Is it clear? So this layer is soft, right? Make sense? Loose areolar. And this layer is hard because dense connective tissue. Okay? So the microorganisms can easily penetrate, enter into this layer and spread, or injury can easily occur in this layer. Makes sense, right? Because this layer is soft. Soft. So injury can occur easily in this layer. But injury doesn't occur in this layer because this is very tough. Okay? And that's why we say dermatitis. You have heard the term dermatitis. Dermatitis indicates the inflammation of the papillary layer of the dermis. Dermatitis, inflammation of the dermis, right? But which layer is affected? The outer layer of dermis. Make sense? Because it is loose type connective tissue. Okay. Thickness of the thick skin is mainly given by the stratum corneum. Remember, although lucidum is only present in thick skin, absent in thin skin, but it doesn't have anything for the thickness of the skin. Thickness of the skin is given by the corneum. In thin skin, the corneum is thin. In thick skin, it is much thicker, like very thick. So corneum gives the thickness of thick skin. It is very thick in thick skin. So here you see, this is the stratum corneum, stratified squamous layer of thin skin, and this is the stratified squamous of thick skin. So it is much thicker than the thin skin corneum. Okay. So if I ask you, let's quickly review. Okay. Skin has how many layers? I say, okay, that's why I asked. Skin. Two. Very good. Skin has how many layers? Two. Outer layer and inner. So you have to understand the question. Okay. Okay. Now, which one is thicker? Dermis. Dermis is thicker than epidermis, right? Okay, good. Now, although dermis is thicker than epidermis, dermis has how many layers? Only two. Epidermis is thin, but it has how many layers? 4 or 5. You have to answer 4 or 5, right? Why 4 or 5? Because thick skin epidermis has 5 and thin skin epidermis has 4. Which layer is missing in thin skin? Lucidum. Is it clear? Now, which layer gives the thickness of thick skin? Corneum. Okay? Although lucidum is present in thick skin only, but it has nothing to do with thickness, right? Thickness is given by the corneum, outermost layer. Which layer has many stem cells? Which layer of the epidermis has a layer of stem cells? Innermost or outermost? Innermost one, right? Basilis. Stratum basilis, which is also called germinativa. Okay? So you need to know the name of those 5 layers. You see here, these are the stem cells. Okay? Which layer of epidermis has many layers of squamous cells, dead squamous cells.
Corneum.
Outermost one, right? Corneum has many layers of dead squamous cells. And those cells are heavily filled with what? Keratin, that highly specialized protein that gives the waterproofness, right? And toughness of the skin. Okay, so you can see the pictures of the skin. Now, the term keratinization. Keratinization is the process. Keratinization is the process by which, you remember I said in corneum you have many what? Squamous cells, right? Dead squamous cells filled with what? Keratin. Is it clear? Now, how those cells get filled with keratin, that process is called keratinization. Is it clear? How those flat, dead squamous cells get what? Filled by keratin. That is called keratinization. So what happens, you see, we have one type of cells, those are called keratinocytes. Keratinocytes. In the deeper part of the epidermis, we have keratinocytes. And keratinocytes are the cells that produce what? Keratin. So, these cells, they are called keratinocytes, right? Because they produce and secrete keratin. So, these keratin producing cells secrete keratin, and then what happens? The keratin molecules enter into these dead flat squamous cells, and these cells get filled with keratin. Okay? So this process is called keratinization. The process is called what? Keratinization. Yes.
The keratinocytes, do those
Keratinocytes?
happen in the spinosum?
Yeah, keratinocytes are present in spinosum, in the inner part of the epidermis. Okay. So if I ask you, keratin producing cells are called what? Keratin producing cells are keratinocytes. Okay, their name is keratinocyte, right? So they produce and secrete keratin. Is it clear? And keratin, these protein molecules enter into what type of cells? Squamous, dead squamous cells, right? And make these cells keratinized cells. So now these cells are keratinized cells. So keratinocytes produce and secrete keratin. Keratinized cells are dead squamous cells that are filled with keratin. Okay. And this process is called keratinization. Okay, so dermis has outer papillary and inner reticular layers, and I have mentioned what type of tissue, right? Areolar is papillary and reticular is dense irregular in reticulum. So here you see papillary layer of the dermis. This part is the dermis. This is hypodermis, adipose tissue of fat. Okay. So this is dermis, outer papillary, inner reticular. Papillary gives how much thickness? 20%, right? And reticular layer, 80%. Okay. And if you see this picture, you see that most of the skin structures are present in the dermis. Here, you see different structures. In the epidermis, you have only epithelial cells. Now, what are the structures present in the dermis? you have sweat glands. You have sebaceous glands. You have seen this model, right, in your lab. You have Pacinian corpuscles. Remember that? Deep touch. You have blood vessels. You have nerves, as well as tiny muscles. Those are called what? Erector pili muscles, right? Or erector pili muscles. So those are the structures, as well as hair root. This is the hair root. Hair follicle. This is the hair follicle. Okay. So only the shaft part of hair is exposed to the outside. Hair follicle, hair root are inside the dermis. So you see, most of the skin structures are located in the dermis. One more thing you need to know. Dermis of the skin is vascular. That means you have blood vessels. Epidermis doesn't have any blood vessels. So this is something you need to know, that dermis has blood vessels here, but epidermis doesn't have any blood vessel. Now, how these cells get nutrition and oxygen? By diffusion from here. Okay. So from the underlying dermis, by diffusion, nutrition, oxygen enter into the epidermis. Is it clear? So no direct blood supply. Now you tell me, since the nutrition and oxygen enters from the dermis, these cells get more nutrition and oxygen. Make sense? Because these cells are close to the dermis. And these cells get what? Less. Right? And many of these cells are dead cells. Now it makes sense, right? I said many of these cells are dead cells because they are far from the dermis. So the outer layer cells are dying all the time, right? Right. So if outer layer cells are dying, then you need to do what? Produce new cells, right? Skin needs to continuously produce what? New cells. And I have already mentioned, these cells are the stem cells, right? In stratum basilis, remember? So these cells are always multiplying by mitosis to produce new cells. Is it clear? So these cells are dying and getting out from the body, skin, and these cells are producing new cells. Now, for one cell, new cell, to move from here to all the way to the stratum corneum, it takes about 25 to 45 days. 25 to 45 days to reach from here to the corneum. Water loss through the skin. So we lose water from the body in different ways. Water gets out from the body. We divide them into two types of water loss: sensible and insensible water loss. Make sense? Sensible, that means you can feel or see that water is leaving. Is it clear? Insensible, that you don't see. Name is telling you, right? Sensible, you can feel or sense or see. So tell me, what is the most visible way of water loss? Sweating is one, and another, a lot of water gets out.
Is urine.
Urine, as urine, very good. So those are sensible, right? When sweating occurs, you feel, you see, and urination, of course, you see, right? Insensible water loss. Some water molecules are getting out when you breathe. Respiration, right? Breathing, water is getting out. Another is through the skin, not only sweating, another way water gets out, that is called evaporation. And evaporation occurs 24 hours, even when you are sleeping. No sweating, but what? Evaporation. Okay? Water molecules are getting out, right? So, you know that. Even if you sleep all night, in the morning you feel thirsty. The reason is water, we know we didn't urinate, we didn't sweat, but water left from the body through what? Breathing as well as evaporation through the skin. Okay? So those are insensible ways of water loss. So if I ask you through the skin, which way we lose water? Both sensible and insensible. Sweating is
Sensible.
and evaporation
Insensible.
insensible. Make sense? Color of the skin. This is something, okay, this is very complicated. Now sometimes people fight against each other because of
Color.
the color of the skin, okay? But you know that color is mainly given by which pigment? I said melanin. Remember that? So some people have more melanin, some people have less melanin. And that should not be a big issue. So if you know, you do that. Okay, now melanin is the main pigment that gives the color of the skin. Dark skin has more melanin than the light skin. That is number one. Melanin has an important function in your body. That pigment, melanin, makes a layer in the skin that is called melanin shield. Against what?
Sun.
Sun, UV radiation. Okay? So UV cannot pass through the melanin shield. So it protects against UV radiation. And you know that UV radiation is one of the main causes of skin cancer, right? So the melanin shield protects the person from skin cancer. Another type of pigment present in the skin in trace amount, very small amount, that is called carotene.
Coming from carrot.
Yeah, carotene. The color is like carrot, orange, right? It's yellowish or orange color pigment. In human skin, we have a small amount, I said very small amount, right, of carotene, and mostly in the palms and soles.
This one was sometimes when you sleep and wake up in the morning, you feel like kind of spot yellow, like a henna.
You see near.
Yeah, it just part, like small part. One time I woke up, it was like yellow, orange, like henna.
Yeah, I cannot absolutely say that it is due to carotene. It could be due to breakdown of red blood cell, and you know that bilirubin, that yellow pigment, that could also cause that. Yeah. So, in some fruits, right, and vegetables, you have plenty of carotene, like carrots, oranges, right? You have a lot of carotene. That's why the color is that. In human, we have a small amount. Hemoglobin. Have you heard hemoglobin?
White stuff.
Hemoglobin gives the color of the blood.
Oh,
What is the color of the blood?
red.
Red, okay? So the color of the blood is given by
Black.
hemoglobin. Okay. So now you tell me, your skin has blood flow, right? Blood circulates in the skin. If someone has more hemoglobin in the blood, the skin color will be
Red.
red, pink, right? And someone has less hemoglobin in the blood, the color will be pale. Make sense? And by looking at the color of the skin, you can tell if someone has anemia, lack of hemoglobin. Is it clear? Okay. So that also gives the color to the, contributes to the color of the skin. So those are the pigments. 3 types of pigments. Red pigments are what?
Hemoglobin.
Hemoglobin. Orange or yellow?
Carotene.
Carotene. And dark?
Melanin.
Melanin. Okay. Now, by looking at the skin color or change of the skin color, you can diagnose some clinical conditions. One I have already mentioned, right?
Anemia.
Anemia. If someone has lack of hemoglobin, the color of the skin will be pale. Skin or mucous membrane will be pale. And that will tell if that person might have lack of hemoglobin, which is anemia. Hypertension. If blood pressure increases, the flow of blood in the skin will be more, right? Make sense? So if you look at the person's, particularly the face, it will be flushed face, skin. Tells hypertension. Jaundice. I said, if too much red blood cells